Jane. So I'm Richard Lindsay, University of East London and the IUCN UK Peatland Programme Senior Research Advisor and your chair for today. I will just begin by pointing out that clearly through the lens of policy, policy and politicians and indeed the financial world, the focus is increasingly on carbon. Now we know that peatlands are much more than that, but this session will be focusing particularly on carbon in its various guises. It will be a global view because we'll be including the southern hemisphere, as well as a lot of the sort of landscape that we deal with on a day-to-day basis here. But anyway, we're already running behind time, so you don't need to hear any more from me. Other than to summarise the session, we have 2 Rosses, then we have 2 videos, then, I'm really annoyed about this, we did have a double barrel presentation. 2 people with double barrel names, but unfortunately Garance can't be with us, so we have Ed Salter, unless you'd like to double up your name. Yeah, right. So, so without more ado, I'm going to introduce Katie Ross, who's a postgrad researcher from CH. And she did mention to me that because she's been in the Falklands, she's vitamin C deficient, so if you'd like to throw fruit and vegetables, she would actually welcome it. So I leave Katie to your tender mercies.
Thank you.
You're on.
Yeah, I'm on. Oh, yeah, thank you. Thank you so much for the introduction, Richard. Thank you all for coming here today and listening to what I have to say. I'm going to be talking about somewhere a lot further away than perhaps the locations you're all working, but hopefully there's Hopefully there's some interesting learnings and either ideas that you might have for the Falklands or things that maybe we can learn from this kind of case study. So, superficially, the Falklands does actually kind of look quite a lot like some of the uplands that we're working on. The only difference is, and I'm not sure if this will work, instead of hearing sounds that are more like this is a curlew playing now. It's quite quiet. You're more likely to hear the sounds of birds like these. And rather than kind of worrying about losing your wellies or falling into bog pools, you need to be more concerned about bumping into one of these guys, or even poking one of these with a peat depth rod. But more seriously, the peatlands of the Falklands are actually pretty impressive. For those of you that don't know, they're about 8,000 miles away, and located down near the bottom of Chile and Argentina, down there. And they're pretty cool peatlands. Some people would say that actually the entire of the Falklands is just one giant peatland, although some of the more recent mapping efforts have put it closer to about 43% peat cover, which when we consider the size of the Falklands, which is just slightly smaller than Northern Ireland, puts it at one of the largest peatland extents relative to the country of anywhere in the world. And that's kind of strange because the Falklands shouldn't necessarily have peat. It's right at the edge of the climate envelope for peat formation because it doesn't get very much rainfall at all, particularly compared to some of the peatlands that you get across Chile. And that's potentially reflected in the quite low long-term carbon accumulation rates of about 2.6 grams per metre squared per year. This is from a whitegrass peatland that is perhaps kind of most close to the blanket upland peatlands that we get in the UK. And to kind of put that into some context, for Northern Hemisphere peatlands, long-term carbon accumulation rates are normally between 10 and 30 grams per centimetre squared, that should be actually per year. But yeah, so despite that, there is some pretty impressive peatlands in the Falklands. So they also have, around the coastal fringe, this incredible grass called tussock grass, or Poa flabellata. And you can kind of see there the scale it gets to. So on this image on the right-hand side, you can see some people just walking up through this grass here. And here the peat can form 12 metres deep under these kind of dense mats of this plant that are incredibly well supported by the marine ecosystem, which brings in all this nutrient and helps raise this massive productivity in this peatland. And as a result, the long-term carbon accumulation rates are closer to 139 grams, so like absolutely massive compared to what we're getting in the northern hemisphere. But despite me showing you all these beautiful pictures, unfortunately the Falklands has had 200 years of habitation and a lot of sheep grazing, kind of managed in this ranch-style system. It peaked at the turn of the kind of 20th century with around 800,000 sheep, and it's now declined to about 400,000 sheep, but only about 2% of the Falklands has been left ungrazed. And that's not the only thing that's been impacting the Falkland Island peatlands. There's things that you probably all deal with in your general work, so things like ditching, a lot of this happened in the 50s, burning in the form, a bit like swaling that we get in the southwest, and peat cutting. In fact, we just celebrated Peat Cutting Monday, which is a bank holiday on Monday, although at the minute it's very, very small scale and not many people still partake. So now most of the Falklands looks more like this, with that thick cover of vegetation completely gone. And this is kind of where my work first started, was to try and work out, are the peatlands of the Falklands still sequestering carbon? Are they still doing what we hope they're doing, or actually are they now net emitters? And how is the ways that the land is being managed influencing that? So when I first got there, I had spent a bit of time just trying to understand the farming lingo of the Falklands, which has quite a lot of Spanish and Uruguayan influence, and trying to work out how people graze the land, and also how to set up a research project. So we tried to look towards the Peatland Carbon Code, which is all based around a management intervention. So we wanted to see if we could find lots of different farms that manage in different ways, and then almost measure the emissions from those to see if there's a more sustainable way of managing the land. So this is where we came up with the idea of looking at lots of fence lines, so areas that should ideally be the same either side of a fence line, but a management intervention has now meant that either the vegetation communities and potentially the emissions are different. So we looked at lots of different areas, things that are set stocked, so the sheep are on year round, areas that are holistically grazed, so the sheep are, in some cases, something like 9,000 sheep are moved on an area of like between 50 and 108 hectares every single day. Rotational grazing, where the sheep might be in an area for 6 weeks or more. Areas that aren't grazed, bare peat areas. And then within that, lots of different vegetation communities within the same grazing system, and also where we've got non-native and invasives coming in. So that started a year of field work. So some of you might have worked with these before, these chamber-based measurements where we're directly measuring the CO2 and the methane coming in and out of the peat. Basically, you put a chamber over your bit of peatlands, and you look to see if the CO2 and methane in that chamber is increasing, in which case the peatland's emitting, or if it's decreasing and the peatlands is taking it up. And what did we find? So basically, this is a horrible graph, so this is just for a visual prompt. So basically, if we kind of take an average across all of these sites, and scale it up over considering the light and dark hours over the course of a day, over the course of a year, at a really rough estimate, you get about 0.08 tonnes of CO2 emission per hectare. There's still a huge range around this value, and I want to work on this a bit more going forward to separate it out a lot more based on land management, and also control a lot more for the weather conditions at the time of all different measurements. But to kind of put that in a UK context, if we look at some of the 2017 data, you can see that it's potentially emitting more than the grass-dominated modified bog that it perhaps most best resembles in the UK, but not as much as the eroded modified bogs. And I kind of want to give you a couple of examples of what we're seeing. So I've just pulled out two here linked to land use. So this is a September measurement, so this is just at the start of spring in the Falklands. And this site down here, this is an area that has not been grazed in about 25 years, contrasted with a site that is holistically managed. And we can kind of see that it looks like the site that is being grazed has more emissions than the site that isn't being grazed. And then if we go to this site, this one was taken on a slightly sunnier day, this measurement, so that might be why there's more uptake. But yeah, if we look at this site, this area on the left is an area that was being set stocked, so the sheep are in there year round. And we can see again that there's potentially slightly higher emissions, or at least less uptake than the area that is being managed on rotation. However, that kind of all falls apart when you get to December, the height of summer. And actually there's very little difference between all of these different management styles. And that could be because it might not necessarily be the way we're grazing the land that is the most important. It could be more down to water, given that these are wetlands. So again, in spring, we can see that the water tables are actually quite different depending on the grazing systems. But when you get down to the summertime, all of these water tables are dropping quite a lot and becoming quite similar across the islands. So it might be that in the Falklands, it's more important to start thinking about how we manage the water better rather than how we look at just grazing. And just to pull out a couple of examples of that, in some places I was looking, the water table was dropping as low as 140 centimetres in some areas of peat. And in other areas, this one on the right, this was a 50 centimetre deep peat. And in the height of summer there, the water table had dropped completely from the peat below into the clay layer, so that was completely dry. But while we're talking a lot about water tables and carbon emissions, I think it's also important to note that not all carbon is lost as a gas, as CO2 or methane. In the Falklands, they're particularly susceptible to just erosion of peatlands and the carbon that's lost with that. So I kind of gave a poster on this on Tuesday, so I might skip through this a bit more quickly. But we also wanted to try and measure how much carbon is actually just being lost through erosion rather than the fluxes. So we set up a load of these passive sediment samplers that work as the wind blows across and it carries any material. This gets collected in the sampler and you can empty it and weigh it and look at the carbon content and try and work out how much is blowing around these systems. And we also looked at the eyes on the bog techniques as well. So we put in lots of surface level rods, which I'm sure you've all used to see if there was any loss of material there. And just quite quickly, what we found is this one here probably really stands out, this really big bar. So we're kind of getting erosion from lots of different sites year round, but this big one really stands out at about 600 grams per metre squared per day. And what that's telling us is that on some of these bare areas, like this one here, CPB, we're getting 600 grams of peat moving through the air per metre squared per day, which is absolutely huge. And when we try and think about, is this the same in the UK, what's happening there? When we look at areas of the fens where a similar technique has been set up, we're only getting about 5 grams per metre squared per day. So this erosion is a huge problem in the Falklands, and potentially if you want to develop a peatland carbon code there is something that needs to be looked at. Now, not all of that erosion, not all of that material moving around is peat. There's a mineral component to that, so actually when you just look at the carbon content, that probably drops for that highest one to about 170 grams. But that's still pretty massive. And again, we found that the biggest driver of these high numbers was soil moisture. And again, like really, really rough estimate, scaling it up to about 0.008 million tonnes of CO2 equivalents per year could be being lost just by this erosion process. Luckily, the Falklands government is kind of starting to pick up on this, and they're now putting weather stations all across the Falklands to try and see how soil moisture and rainfall patterns vary across the islands, which will be useful for us as we start to upscale some of the chamber-based findings. We can see how representative they are of the wider landscape. And some of the microbiology and organic geochemistry work I'm doing will help us kind of fit in and see how it might vary and influence the fluxes across the Falklands. And I realised that was kind of quite quick rattle through some science, and not all of you are really interested in the science and research side of peatland. So I thought I'd finish with a bit of some of my learnings from the Falklands, and also things that we might be able to learn from them. So it's been really inspiring hearing a lot about the telemetry that's going on in the UK and the different organisations that are using that. I really struggled in the Falklands because there was only one weather station. This one was new, actually I put this one up, but there was only one working weather station and it didn't have wind data for 3 months of the year where the sensor was broken. And there's no option to do telemetry at the minute, so you have to manually download everything. And similarly, it can be quite tricky working in an environment where there's only 6 people in the entire environment department who have to think about pollution and marine management areas and don't really have a huge capacity to consider how to bring in peatland policy. But on the other hand, because there's so few people, it's quite easy to try and sit down and have a meeting with the elected members of government and kind of share your concerns and talk about peatlands. And while I think it can be a bit of an interesting environment to work in, I think one thing that's really inspired me and one thing that I hope to kind of share with you guys is actually how much the landowners themselves are doing to try and reduce their carbon emissions, to try and almost restore or manage their land better. So there is, in the UK, we have quite a lot of our direction is from the NGOs or from policy, kind of explaining to landowners how we think they should be managing their land. But here, there's less of that support, and it's the landowners themselves really taking action to try, and they are seeing their land drying out and they're wanting to do things about it. So they're learning how to do monitoring work, and they're not scientists, they're learning how to do that. They're starting to set up fixed position photography just so they can see how their land is changing. They're starting to replant areas and doing lots of trials and trying wall dags or spreading seaweed just to work out what might help these plants grow back. And they're reaching out to organisations to try and do peat depth mapping, and they're starting to go out to carbon companies to see if they can start trading that themselves. So I think it's really inspiring working there, seeing actually how much of the conservation and restoration is being really driven by the landowners, and I hope that's something that we can continue to bring into some of our work. So yeah, thank you very much. That was a quick rattle through, but hopefully you're more on time.
Questions? No? I have an observation. Oh, right, thank you.
I'm fascinated. The original European settlers, when they arrived in Falkland Islands, sent letters home saying that there was a huge area of exposed dry peat, and you could cut and burn the peat straight away. So how much do you think you're observing which was actually a natural phenomenon, which we're now trying to, if you like, rectify? We're trying to alter a natural process in order to be able to store more carbon, because that's actually what you do, and that's an admirable aim. But how much are we interfering with the natural process, and how much of it is actually driven by degradation influenced by man?
Yeah, that's a really interesting question. So it's funny, I was reading something the other week actually that says almost erosion is the end point of peat formation. Peat can only form for so long and then eventually will destabilise and start eroding. I think while there's so I was reading through some old diaries written at the time that suggest some of the sites that I'm working at, these erosion features have always been there. But I think at the minute we're seeing erosion at an increasing rate in places that it's not being observed before or recorded before. So especially around this coastal areas, coastal fringe where there's tall grasses growing. We know from earlier records that those were almost entire fringe coverage around the Falklands, and now there's only about 1.2% of that left. So we know that in places like that, actually, erosion predominantly from grazing, but also from fires in these areas, have really changed the landscape there.
Thank you.
Yeah.
Thank you. Another question? I have an observation. Almost the first thing you said was that it's amazing there's blanket peat on the Falklands because it's right on the climate envelope. But of course what it does have is lots of cloud cover and fog and mist and so on. So just really highlighting the role of occult precipitation. So precipitation that doesn't get measured as rainfall. In this case is clearly really helping the formation of peat, and we are just not measuring occult precipitation. So when we're talking about blanket mire and whether raised bogs can form, I think we need to be considering that. It can be a significant contributor, and Katie has demonstrated that brilliantly. So thank you very much, Katie.
Thank you.
Right. So we move on to the next Ross. So Ross Morrison, well actually, you don't really give yourself a title. He's basically carbon flux guru for the CEH. So I'll leave you to explain what you do.
Thank you. follow up Katie's barnstorm there, but there you go. So yeah, I'm Ross Wilson. I do have a job title. I'm biometeorologist at UKCH. So what I do for a living is I lead this thing called UK Flux, which is our national carbon monitoring programme. Is this going to change? Yeah, okay. So I'm standing up here talking about this just now, but this is a massive national scale thing that we do. And soon we'll be in Providence as well. So, there's a whole load of people that are involved in this, many of them at CH, and then it's a huge community effort as well. So we have a whole load of people that I need to acknowledge, the people that fund our work, the people that host us, the people that speak to us, and then ourselves, we're also a part of a much larger global initiative which is designed to understand how the biosphere breathes, how the carbon, water, nitrogen cycle of the terrestrial biosphere functions globally. So what do I do? So this is, some of you would have probably been and seen these things yesterday. I'm sure you can't go anywhere these days without hearing about the flux count if you're interested in carbon. So UK Flux is CH's initiative. So this is a flux tower in the middle, but the technique that's used is something called eco-variance. And for years and years and years we were kind of doing this, and it was kind of a little esoteric sort of science thing. There's a few of us who do micromet and biomet, and then recently it's really kicked off in a big way. So what we've always been asking using this technique is, what is the greenhouse gas balance of the land and the water surface? You can do this over the ocean, you can do it over lakes, you can do it wherever you want really. How is it changing, and what is controlling the changes? More recently, the whole thing has shifted slightly, and the way we do things has shifted slightly into, can we, not just understanding the system, but can we manage the system in a way that's productive? Can we put more carbon into certain types of ecosystem? Can we plug gaps? For example, agricultural peatlands, large amounts of carbon. Can we do things in order to either store more carbon and or reduce the greenhouse gas emission? If we are able to do that, what are the trade-offs, and co-benefits of that, in terms of the water cycle and that sort of thing, biodiversity? If we are able to do that successfully, then how permanent are the carbon stocks we put into those systems? So, for example, if there's a big environmental change, a drought, for example, is there going to be a big carbon loss? Have you created a new risk? And then increasingly, it's becoming important for this whole MRV thing. So things need to be measurable, reportable, verifiable if you're going to enable carbon markets and that sort of thing. So this map here, this is the peak component of UK Flux. The sites in Scotland are all run by my colleague at James Hutton Institute, Rebecca Arts, and then everything below Scotland is UKCH and Friends. So these are just the peak sites, the grey dots that you just see in the background. We also have a sort of parallel network that's doing mineral soils and various other types of ecosystems. It's out of date because there's a whole load of new stuff that isn't on that map. This is what it looks like. So that's, everything kind of kicked off in 2019 because net zero became a thing, and everyone with land holdings all of a sudden thought, I could use my lands in order to balance out for net zero. The idea is you need a biospheric sink to balance off emissions from hard to decarbonised sectors. So it's got a bit crazy. This is, John, you probably recognise this. This is Ballyhone Bog, picture in the middle. But that's the kind of stuff we do. So everything in green on that graph at the bottom left-hand side, that's the peat side. So we do a whole load of stuff in conservation. We do a whole load of work on agricultural peatlands. Something we're starting to do a lot more of is engineered greenhouse gas removal, which also you can do in peatlands. We're testing that. We're starting to do loads of work on salt marsh. Woodlands are still not something we're doing a lot of. And the thing that's about to come on is paludiculture. We're not really doing a lot of that. This is what's sort of expected by the end of 2023, or the end of this particular financial year. These are data that come out front. So it's very powerful technique. It's very useful. They measure very quickly. But what we do to the data is we get a flux density out of these systems every half an hour. So it gives you very, very high detailed information of what your ecosystem is doing over a large area. It's an ecosystem scale technique. It's big. So these are just some example data. On the left, you've got, it's a weather station. So we've got a whole load of meteorology, radiation, temperatures, energy balance. That's the bit that actually is important to climate change, how the surface interacts with the atmosphere above it. So latent heating, sensible heating, air temperatures, soil moisture, water tables. Down the middle there, your carbon fluxes. So in that top picture, they are 30-minute flux densities measured using eco-variance over this bog in Northern Ireland, Ballyhone. The red, that's the methane. And then when we start to use this, we take these data, we get 30 minutes later, we add it up, and there's this carbon balance. So in the next one down, that's daily emissions and losses of carbon. Anything that's negative, that means it's been sucked out of the atmosphere. Anything positive is an emission. So the red is the methane. We can do some clever modelling with some ethanol down, the GEP and TDR, we can read that so we can understand how much photosynthesis is happening, how much respiration is happening. And then the thing that policy and other people are interested in is the one at the bottom, which is the accumulated emission. So we accumulate these over time. The black line there, in this particular site, that's showing that that site is acting as a sink, so it's going negative, and the red line is the methane emission that's balancing off some of that carbon emission. I'm not going to go into water, but we also do the same thing for hydrology, and we can, that's becoming an ever-increasing part of what we do. Just some examples of this. The way we're doing this is kind of changing a little bit as well. We used to do things like single sites, and now we're very much focusing on things like gradients and things like before, after control intervention experiments, which are more expensive because you need more than one flux tower. So if you're interested in what your land is doing, you need to have a control and you need to know what happens after that's happened. This is just an example. So this is taking all the raised bog sites we've got. So you have a gradient that goes from Gary Bog, which is quite a nice condition. Of course, Coron, which is also quite a nice condition. Bainham, which has been drained and re-wetted, and Glenallen, which has very recently been re-wetted. And what we can see from that is actually what you'd expect really is the carbon. They're kind of similar in terms of carbon balance on an annual basis. These are data from April 2022 to April 2023. But the site that is currently emitting is the one that's most recently been restored. You can't expect that. The changes happening because it's only just got off it. It's still sort. So the next question will be how long it takes for that to start functioning, resembling what's going on in the other sites. The other one, that's methane, so that's the same thing. So that's just sequestering carbon, you're also offsetting that with some methane. The other end of the scale, this is something that I probably do most of my work on, which is croplands on low peat. So you've been out and about in East Anglia yesterday, you've seen what these things look like. So that is the peat area in this region. So some deep peat, but quite a lot of skirt and wasted peat, shallow peat. And then this is the same thing, but you can see it goes in the opposite direction. These jumps, these step changes, that's because a cropland isn't nice and easy like a bog. You need to do the mass balance. So by definition, you grow crops and then you cut them and you take them off. So you have to account for all the different flows of carbon. And then what you see there, the wasted peat site, they emit less carbon, less of the source. So still the carbon, they emit less than a shallow peat and deeper peat layers. This is a graph that Chris showed us on Monday. This is our graph that we did a few years ago. We collected all the Peatland data, all the annual values, and related this to water levels. When we first published the paper, nobody really noticed this, but we had a linear relationship that describes the relationship between greenhouse gas emission and carbon loss. If you think that through, that can't really happen because if you keep making it wetter and wetter and wetter, eventually you've got a lake, and that's not really how lakes work. And on the other end, you can't just keep emitting carbon forever. So we've been working on this relationship quite a lot. The first one, this is what it looked like at the end of last season after we'd done a whole load of projects and accumulated data. And then because I was coming to give this talk, I thought it was quite a nice time to update it again. So we're bending this curve a little bit. So as we add new data to this, the relationship's still pretty good, it holds, but this S-shaped curve is becoming more realistic. So we're continually updating this and also testing this. The bit that's probably quite interesting is the residuals. So water level, it's really good as a predictor, but maybe we need to understand better of what's controlling the residual there. Question, I'm preempting a question that somebody will probably ask me later. So what about nitrous oxide? So nitrous oxide is something that's incredibly difficult to measure. So those of you who went to Wickham and Luke Palmer's farm yesterday, you would have seen this one here in this field. So this is the only currently operating N2O flux tower that is in the UK. We have three of these. One is on Telecom Tower, one is on the Scottish grassland, and one is there. So this was really interesting, really. So what happened at this particular place is that we had 2021 was irrigated potato, and quite wet year. Wheat in 2022, beans this year. It's unusual for peat because they're legumes, so it's quite interesting. But what we saw for the N2O was massive additions of N2O during the irrigated potato year. This doesn't actually correlate with anything if you look at it on a 30-minute or a daily basis. But the thing that's driving this, as far as we understand, is the fact that you're irrigating with ditch water. So you're potentially putting a lot of labile nitrogen out of your ditches onto your site, and then that's kicking up both the nitrous oxide emissions. So that we haven't budgeted this yet because the methodology for this isn't quite as advanced as the carbon and water. But the next stage of this is we're going to pair up two end-to-road sites and look at the differences between irrigated and non-irrigated in the same year. So that's potentially quite significant for, you know, the greenhouse gas balance of agriculture. And you know, the sort of crop selection you might go for in the future. Yeah, so obviously, you know, agricultural peatlands are a bit of a nature-based problem, but there are chemical solutions. So this is just an advert really for something that we are doing with some of the farmers who are here today but not in this room. So we are setting up some trials. This isn't using any chemical, this is using, you know, sort of standard sort of agricultural trials. We're going to do, you know, these are going to be big. We're going to set them up. I'm not going to go all the details down there. But they are kind of, we can try everything. So we're going to go from, you know, native wet woodland, which is a lot of the thing is actually made out of, to things like mixed species, rich grasslands, reeds and typha, which are your kind of polyculture crops that you'd expect. Some of the more extreme bioenergy crops, some people might think. And then some novel stuff, you know. So we'll have agricultural controls, and we're going to measure this using a different kind of gizmos. It's a skyline 2D, which is like a zip line that goes up and down this thing and drops down this bucket and takes some greenhouse gas emissions. So it's very useful for doing trials, and then we'll do some manual greenhouse gas emissions. The idea of this is in 3 years' time we can sort of start to knock out the sort of the solutions that maybe aren't the right sort of thing for these particular landscapes. So that's incoming. And then finally, this is just a bit of fun. So this is a gravel pit restoration. So we're doing this work on engineered greenhouse gas removal using peatlands, and this came up. So this is a site at the top of the ooze washes where we were yesterday. All the gravel's been extracted, and if you sort of think, you know, the RSPB who manage the site, they've got it very wet, and they've managed to get it completely covered in Phragmites. And we sort of, Chris and I sort of thought this would be, is this the sort of place where you might have sort of fluidification? So we set up a flux tower there because we had one spare and measured it, and it's accumulating more carbon than a natural fen in you know, in some requirements, and actually not emitting so much methane. So we were thinking about packing up here. We're going to give this a stay of execution and see what happens next. And then the question is, where's the carbon's being fixed? Is it just accumulating Phragmites and biomass, or is it, you know, is it possible to actually start sort of organic matter and then peat accumulation in this kind of sort of really heavily, you know, I like the idea of turning an extractive industry into something that's kind of different. So that's it. So what I said, UK Flux Network, we're growing this all of the time. It's getting bigger and bigger and bigger. Luckily, so is the team. Peatlands, that is probably our main strand of work, if I'm honest still. We've got loads of new data, new sites, N2O, continually trying to improve our relationships so that we can actually have useful predictive tools. That goes for that kind of simple empirical model that I showed you a minute ago, but also to, we have land models, we have more complicated models like the UK land environment simulator, JULES, which CH have a big role in. So, you know, to try and improve these tools that we can actually make future predictions and that sort of thing. And yeah, so we're going to start doing a load of agricultural trials pretty soon, which include, you know, hopefully things that are actually going to turn out to be sort of solutions to reducing greenhouse gas emissions from, you know, the heavily emitting agricultural peatlands. That's it. Thank you.
Thanks.
How long did I go on?
13 minutes. Very good. Yes. On a UK-wide basis, are there any particular areas where there are gaps in the network that we should develop?
Yeah. There's the pendulum of what we do is kind of shifted a little bit from, you know, we started quantifying that we used to do a load of work in the uplands, and then we realised that the greenhouse gas emissions were mostly from peat, mostly coming from the lowlands, and so a lot of our focus and a lot of the funding focus shifted from uplands sort of work to the lowlands. So we've got like 10 of these things running in the East Anglian Fens, for example, but 3 or 4 in the uplands of England and Wales. So yeah, there's a big back, and so we've sort of shifted away from bogs towards lowland fens and polyculture and that sort of thing. But so what that's done is it's left the sort of other areas of UK peat haven't really kept pace. So yeah, we are data sparse in upland peatland landscapes basically. And there's many actually. people are coming up with new, novel ideas all the time. All these things need to be tested. So those are there's emerging, there's known gaps, and there's things that are emerging and changing quite quickly. So.
Sort of thinking about, how many are there on high altitude mining bogs?
Two.
Where are they?
One is on a royal estate in Scotland at the top of the hill, and the other one is at Moorhouse in Cumbria. There's potentially more in
The next video or presentation is video by Hans Houston, who is Professor of Peatland Science and Paleoecology at the University of Greifswald in northeast Germany. But really that's not what he's known for. Hans is essentially Mr. Peatland in all international peatland-related intergovernmental treaties. Hans, there isn't a peatland event across Europe without Hans. He and I were speaking at Antwerp just a couple of weeks ago. So we're going to hear his thoughts on methane, and I just need to hit play.
Hello, from Germany to the UK. The organizers have asked me to tell you a little bit about methane. Why? Because that is the question you always get. When we talk about rewetting of peatlands, the question is always asked, but what about methane? We all know that drained peatlands are huge emitters of greenhouse gases, specifically CO2, carbon dioxide. That is actually what is heating the climate. Drained peatlands emit a lot of carbon dioxide. And really the drained parts, they do not emit methane anymore. But the drains itself, the ditches, are actually hotspots of methane emissions. So it is not so simple that you can say drained peatlands do not emit methane anymore. But indeed, if you rewet peatlands, then you actually reinstall the methane emissions that were stopped as a result of drainage. That has to do with the fact that actually the same process that allows the sequestration of carbon as organic matter, the anoxic conditions, are exactly the conditions that cause a minor part of the organic matter to be broken down under anoxic conditions and to produce methane. So the rewetting of peatlands is always a question of choosing between carbon dioxide and methane. And if you have to choose between carbon dioxide from drained peatlands and methane from rewetted peatlands, you always have to go for the methane. Why? That has to do with the fact that methane is a very strong greenhouse gas, but on the other hand, it has a very short lifetime in the atmosphere. After 10 years in average, it is gone. Whereas carbon dioxide is a weak greenhouse gas, but it accumulates in the atmosphere where it persists. In principle, every ton of carbon dioxide increases global warming, and that is not the same with methane, because initially, when methane emissions take place, the concentration of methane in the atmosphere is increasing, and as a result, the climate is getting warmer. But because of its short lifetime, after a while, and then we talk about some decades, the same amount of methane is disappearing from the atmosphere as that is actually any year added as a result of continuous methane emissions. So if you have to choose, always choose for the methane. And that is, of course, the difference with cows. Cows also produce methane, and some farmers said, yeah, if methane emissions from peatlands, rewetted peatlands, is not that bad, then the methane emissions from our cows is also not bad. But cows do not have these huge carbon dioxide emissions in drained conditions. It is a balancing between CO2 and methane. But indeed, methane is a strong greenhouse gas. And if we manage to reduce it, it is better for the climate. So first, we will get, after rewetting, a methane emission that leads to climate warming. You can compare that with when you have appendicitis and you go to the hospital because otherwise you would die. Then the doctors first make it worse. They cut you open to remove the appendix. And in the same way, you can consider the methane emissions directly after rewetting to be. It increases the climate heating, but after a while, it gets stable and it is compensated by first the very strongly reduced CO2 emissions, and secondly, if you are lucky, also by a renewed CO2 sequestration in the newly built peat. But because methane is such a strong greenhouse gas, we should take care that its emission, the volumes that are emitted, are as small as possible. And happily enough, we understand more and more how we can manage methane emissions after rewetting. That has to do with, for example, avoiding prolonged summer inundation, through which the microbes produce a lot of methane. It has to do with removing fresh biomass before rewetting, because it is specifically the fresh biomass that are methane generators. It has to do with avoiding submerged plants that are under anoxic conditions and produce methane. You can also think about sod removal. A lot of agricultural soils are very nutrient rich and have a lot of fresh roots in the topsoil. If you remove 5 to 10 centimeters of this very polluted and very organic matter rich, fresh organic matter rich material, you can reduce methane emissions with 80% or something like that. You can think about regular flooding with sulfate-rich water, what we do, for example, in coastal miles. And we have to think about the rapid re-establishment of resistant peat-accumulating plants, which are not really shunt species, chimney species that lead methane from deep in the soil to the atmosphere. Specifically mosses. Peat mosses are very good. If you have the establishment of a nice cover of mosses, then the methanotroph microbes that eat methane remove actually the methane, and nothing is going into the atmosphere anymore. So we have important lessons to learn with rewetting. First, always rewet as good as possible. Secondly, do it as fast as possible, so that any peak in climate warming that may arise as a result of rewetting comes as soon as possible, and not when we have maximum climate warming around 2050. And third, but not the least part, try to reduce methane emissions with the management options that I just have explained. I hope you have a very good meeting, and I hope next time that I can be with you again. Bye-bye.
So nice, succinct story about methane there from Hans. You can see why politicians like listening to him. He just boils everything down to a very simple story. Sorry. So, yeah, that's that. Thank you. So our next speaker is Professor Fred Worrell from the University of Durham. He's a soil biogeochemist. He's probably most widely known within the research community for his work on dissolved organic carbon, DOC, but he's also now working a fair amount on biochar and its potential role in the enhancement of carbon accumulation within peatlands. He can't be here with us, but he has sent through this video.
Well, good morning. My
My name's Fred Worrell. I'm Professor of Environmental Chemistry at the University of Durham, and I'm sorry I can't be with you in the conference today, but I've been given a slot for 5 minutes to talk about the case for enhanced carbon storage in peatlands. This is work sponsored by Natural England, so thank you to Julian, and thank you to one of my PhD students, Emily, who actually has done a lot of the hard work on the ground. So I'm going to propose there's a problem with peatland carbon. Peatlands, as we all know, are a great store of carbon, and we all have our favourite, statistic or trivial point that there is more carbon stored in the peatlands of the UK than in the forests of Britain, France, and Germany combined. Those sorts of numbers are real and often quoted. We know that natural accumulation rates on peatlands are of the order of 1 millimetre a year. That's a little optimistic for the UK, but it's a reasonably round, it's a good number to start with. So a functioning peatland will be accumulating carbon from the atmosphere. Again, that's a good thing. However, time for us is relatively short. We have net zero targets for 2050, so that is 26 years away. And that actually means that we have to do activity now, and it means we have to do a lot of activity now. Carbon price is very low. Green finance markets really have been often discredited, particularly over the summer. If you think of some of the major green carbon credit schemes have actually been abandoned or at least come under quite heavy scrutiny. So the opportunities for green finance, self-sustaining green finance, has actually been relatively limited. And many of our big wins in terms of restoration have actually now been restored. They're getting rarer. Not that restoration is a bad thing and we should go after all restoration. I would make that case later on. But perhaps some of the extensive bare areas or gullied areas that we're familiar with of some of the Pennines have actually already been quite effectively restored. So some of our big wins have already happened. What this means is that peatland carbon sinks really aren't quite big enough in the context in which we're operating. They're just not large enough with the actual net zero targets in mind and with the potential that we currently have. That's not to say that the capacity isn't sometimes large. If we look at lowland peats, and that's a picture of Hatfield moors, we can see that these have often been cut over and peat extracted, which means that there is a fair amount of capacity to actually infill. A couple of meters in most of these cases. We can think of those, we can think of the home fen post and those sorts of areas where meters, the natural environment there would support a far deeper peat mass than we currently have. So there is capacity. Even in the uplands, and that's a picture of pre-restoration Bleak Low there, what we're seeing here is that, yes, gullies, bare areas, grips, those are accommodation space. They're capacity that could be infilled. And of course, we have area. So all of their capacity has to be multiplied by the area of that type. And that again is a Google Earth image of Hatfield moors. So 16 or so square kilometres that is missing several metres of peat. So what we would suggest is that for a positive impact relative to net zero, we have to actually enhance the carbon storage. The natural carbon storage, even with restoration, isn't actually big enough for our net zero target. So what do? We infill with a refractory, natural, organic matter. Biochar is an obvious candidate that is often talked about. And although biochar is actually considered often a wonder material if you read the literature or if you read the pseudoscience literature, we can actually experiment with it, and that's what we've been allowed to do. We have a range of cells and a range of locations and plots that are trialling that, and we've been doing that for 18 months. But typically, our most extensive treatment is 2 centimetres of biochar. So if you think about that, that's 2 centimetres is about 20 years of peat growth in one go, but it's also of not of peat, but a biochar, which is 50% more carbon rich than normal peat material. So in reality, it's 30 years of peat growth in 1 year. So it is accelerating that peat growth. What we've got to ask ourselves is, does that actually do any damage to that particular habitat? We're claiming that this habitat needs to be infilled to get back to where it was, and so therefore we don't want to damage it. We're also claiming that in fact we are helping that restoration process. We want a natural raised bog surface, and therefore we want it 2 or 3 metres higher. But we want it to be a bog surface. We don't want it to be a landfill of black biochar. And we go on and we monitor lots of things about that to understand its impact.
I'm not going to show you those graphs this morning. What I'm going to show you is some pictures of those results that show, in effect, we have succeeded in these cases. We haven't killed anything, is one of the important criteria. In the image there, you can see cotton grass going through biochar in the background. And the central image, you can see sphagnum actually growing on biochar. Yeah. So biochar is typically assumed to be alkali, and ours was about pH 8, onto a bog that's at pH 4. Sphagnum tends to like acid conditions, but it was growing on the alkali material. And the final right-hand image there is you can see those are some of our plot trials. There are 3 plot trials in there, one of which had 2 centimetres of biochar added. I actually challenge you to work out which. That cotton grass is thriving. So 18 months on, 2 centimetres of biochar doesn't seem to have affected the functioning bog, i.e. we could probably do it again. So 30 centimetres of peat equivalent, 30 years of peat equivalent in effectively every 2 years. So what are we saying? Biochar had minimal impact. Nothing died. Seriously, nothing died. We didn't lose a bird. We haven't counted insects, but the plant growth, the natural plant growth, in this case sedges and mosses, actually grew on top of it or grew through it. Therefore, we are improving carbon storage. There was a slight rise in respiration rates, but actually compared to the amount of extra carbon that had been brought in, we're still storing extra carbon. As I said, rough rule of thumb, that's about 30 years of peat accumulation in the equivalent of 18 months. However, that's all the good news. The bad news is it's probably impractical and uneconomic. We already know that the carbon price doesn't really support very much. And equally, what's the price of biochar and what's its availability? If you imagine an area of 10 square kilometres and raising it by 2 millimetres, you need tons and tons and tons of biochar. Nobody's producing that much biochar, and the price of biochar is prohibitive compared to other restoration costs. So what we're saying is maybe biochar and enhancement works, but is it yet really possible? So to conclude, peatlands are great stores of carbon, and one of the easiest ways of keeping that store of carbon is to restore. The best means of defence is attack. Peatlands aren't great sinks of carbon compared to the net zero window and compared to the other things that are around. You'd be better off growing a tree, frankly. So enhancement is one way around that. We actually bring in carbon onto our sites actively, and enhancement has so far done no damage and so far done what it said on the tin. However, it's currently too expensive, and so we have to look for potential alternatives to that. So my email address is at the bottom there. I'm sorry I can't be with you in the room, and thank you very much.
Okay, so some interesting thoughts there from Fred about biochar. It's very clear we are going to be hearing a lot more about biochar one way or another over the next few years. So Fred raises some real issues that we need to consider. We're back to live talks now. And in place of Garance, we have Ed Peatland Salter, who is going to be talking about the data gaps that we need to resolve in order to help improve. So,
Hi everyone, I'm batting for a grant today. I found out breakfast I was doing this, agreed to do this, so instead of a fluid presentation on peat and carbon data gaps, I'll be monotonously reading from my notes, which are very good. So, I'm not Grant, I'm Ed Salter, and I would describe the difference between our roles as Grant looks to the future. I kind of try and take care of the present, and Renee does absolutely everything. I kind of work with, from registration, keep the process moving, try and get everything done, validation. If you want PIUs released, I'll try and make that happen. I'm still working on that, Betsy. So, where do I go here? Is that right? Perfect. At present, both fluticulture and forest bulb are not included in the Peatland Code, and in order for them to be, we do require more research and data, and to be able to confidently include them in the next version, we obviously try to be a high integrity code. For fluticulture, research commissioned by DEFRA from CEH, JHI and SRUC proposed a methodology that could be used to verify GHG emission reductions for fluticulture, which opens up the possibility of including them in the code for the first time. For forest bulb, we've got a little further to go, as the Peatland Code would like to have a condition category within the code for afforested and felled sites, but we're still working on this as a group baseline. The difficulty kind of is to do with the carbon accounting and who takes responsibility for that, obviously. Currently, we have limited data for the whole of the UK to derive specific emissions factors for peatland restoration on formerly plantation forestry sites. We're still unsure of the total area of forested peatlands in the UK as the figure estimates, but we need better mapping of these areas as well. Fluticulture. It's a relatively new term in the UK. It's used to describe farming and agroforestry systems that are suitable and adapted to wetland habitats. I'm really pleased Hans is not here for this because I've always heard him pull people up on the definition of fluticulture, which was coined by him. So he's not here, so that's the definition right. In other words, it's a wetter way of farming in the context of peatlands. Seeks to preserve peat soils by working with our naturally wetter climate. So far in the UK, discussions around fluticulture focused on lowland peatlands that have been drained and converted to agricultural use, such as the East Angling Fens, Somerset and Humberhead levels, and the mosses in Lancashire. However, new opportunities exist for fluticulture on peatlands across all the UK's developing nations. We've identified we need shifting management of drained peatlands under the intensive productive use to deliver wetter ways of farming. In order to reach this, we need to fill some data gaps for fluticulture to be included, and you see some of them on the screen here. And this is what the call for evidence includes. We have the Fluticulture Exploration Fund as well, so we're hoping to get some valuable data from that. First, we need to have high water table management, pre-baseline and post, so these can be and then we need to know the site history, methods and any information about site history that includes those outcomes. There isn't too much to say about this slide other than Clifton is doing a presentation on it later in the afternoon. I definitely recommend attending that. It's available on our website, so read it. Fens we included in the Peatland Code in version 2.0 earlier in March. We have a few projects registered, and we're hoping that more will kick on further off there. It differs from bogs in doing the emissions calculated because we need water table depth, and part of the reason maybe we haven't had as big uptake as we want is we need 12 months baseline data. For forest and bog, we've got a little bit further to go in fluticulture to include in the Peatland Code. We're still working on an agreed baseline. Sorry about this. All over the place. So we don't have funding confirmed, but we're in conversation about that. And over the next 12 to 24 months, we're hoping to include it into a GHG chamber measurements and versus the tower measured fluxes. We'd also like to carry out a short study that assesses the hypothesis that emissions from post-build sites could be as high as the current drained condition category within the code. Combine the gathering and current flux data that could be augmented by water table depth as a proxy for emissions, a bit like we do in Finland. Study testing this would provide assurance that the Peatland Code requires to adopt the precautionary interim category. An initial test study would require a minimum of 4 UK sites, limited number of additional field observations from field but not yet stored. Could also be collected within the next year from locations volunteered by the RSPB, Forestry, Inland Scotland and SSE. We understand it would not be a priority for England, but it would be good to get some funding trials going in Northern Ireland. Another hurdle that we have to overcome, policy challenges on forestry carbon accounting, when that ends and when peat and carbon accounting begins within UK greenhouse gas methodology and the forest bog restoration process. It may require the commissioning of research from groups such as STAG or others around the UK that fully untangle the impact this might have on UK greenhouse gas methodology and accounting. That's about it. As you can tell, essentially it boils down to one slide. If you like data, give us your data. More data, please. And those are, well, Francis' contact details. Contact her if you want. Thanks, everyone.
Thank you very much, Ed, for stepping in at such short notice and to read other people's lecture notes. Always good to night. But you did really well. Thank you. Do we have any questions? Yes, we can. Yes.
Hi there, Jessica from the Environment Agency. I'm interested that when I was saying about how you're hoping to keep biodiversity metrics in the code, I just wondered whether you had any plans for things beyond biodiversity, so as I'm particularly interested in water and like the benefits to floodwaters and also water quality in the future.
We definitely do have ambitions for that. Obviously we have these first 2 issues and biodiversity as well, but that is in our future plan for sure.
Is there any plans to look at shallow peat and also buried peat to incorporate that into the peat code? Because one of the major obstacles for the fens in particular is actually getting 40 centimetres in big enough blocks. A lot of it is now shallow peat, and it feels like there's a big role there to target, in an area to target to incorporate more people to sign up.
Do you want to help with that one, Nick?
Yeah, I'll do. Yeah, I appreciate that. And so the 45 centimetres is twofold why that's in. It's because our minimum project length is 30 years. And we know in the fence we took like from data, we know it's a rough, like we lose about 1.5 centimetres a year. Very average over the fence. That means that 45 centimetres of peat left after 30 years that would have been gone. So you cannot claim any emission reductions post that 30 years. So we are looking at conservation governance to maybe reduce gap to a lower peat act to have a shorter claimable timeline, but we need to ensure it's permanent. So we need to think about how we could do that. So initially we now have 45 centimetres. We might be able to lower that, but I come back to Ed's last slide. We need more data on like buried peats. Like I don't think there's any measurements. Maybe Ross, you might know. Buried peats. No. So without scientific evidence, we cannot include something like that.
Yeah, well, I know certainly a lot of sites and fences big partnership will be more than happy to engage in any studies to look at buried peat, because it's something that we think could definitely grow.
Yeah, that sounds great. Thank you. Definitely, we can definitely have a chat, but we need the funding behind that, because if we have anyone from government, it would be happy. Just going to throw that in there, because without the funding behind that, there is not, we don't have any, like we funding ourselves as a program, so we need funding to be able to do that.
Question, yeah?
The limitation would like get enough data, with funding the reason around more measurement sizes of the quite expensive flux towers. Is that the limiting factor?
Flux towers are expensive, I found out yesterday when this was they're working on getting that down. It is it's something we just don't have. We have we like to be very confident in including anything into the Peatland code. So yeah, we need vast amounts of data to then get through the technical advisory board and executive board. I would imagine expense is one of the major reasons that we don't have more.
And capacity. Because you know the people who do it, there's not necessarily the people that are able to do it. So that's not the university sector is very good at people that are good at remote sensing and good at modelling, for example. But the people, actual sort of the flux data technique in particular is something that there's a big gap, a skills gap. All of our recruitment has to come from the board, which it has some challenges in time to later that. So there is a funding challenge for it, which we've got to automate some things as much as we possibly can. But there's a funding gap and a skills gap.
Is that changing? Like practically down the flux towers, so more techniques being developed, but low cost sensing.
We work with loads of people that want to do it, and we try and build their capacity, yes. There are people that are trying to lower the costs of it to some extent. Some of the bigger manufacturers are starting to take on board and lower their costs. There's all manner of people that are trying to work lower cost ways of doing things. We are doing work with Cambridge University who are developing something that is similar to an infrared tower, but uses what's called a relaxed LED accumulation system. So it uses similar sort of principles, but you can do it cheaper. So we're almost in the evaluation stage of that. So all of these things, if you're going to roll out new methodologies, you need to test them against your gold standards. And that we're a year away from that from the time we start trying it. But the idea is these, if you listen to them, that it would be possible to build these things for a few £1,000s rather than 50k plus. So it needs to happen, and it is happening, and we're helping people do it, but it's not easy. So it is,
Just follow up on that, you were thinking about skills gap, but what can we do to sort that?
The flux tower technique in particular, you need to be creative. There's a lot of physics in it. You have to read and have to get into be able to weld. So you need to. The argument university setting is just trying people to do the actual measurements as well. And technical side, we struggle with technical people. So there's some very good, skilled technical people, but they are rarer than the scientists. So those are the gaps that need to be. But apprenticeship, you do all sorts of the technical side of things, but there's all manner of ways you can build capacity. It just needs, in my opinion, a bit of imagination beyond the way we currently do that. So projects could have some people associated with it, and we could have trained people.
Okay, question behind.
Yeah, I'm just wondering, as project developers, could the Peatland Code possibly put out a template for the type of data that you want, possibly annually, and then it could either be voluntarily every year, we can give you that data kind of entirely collected for you to then process, or potentially could you comply project developers to give you annual data if it's all part of basically making the code more robust?
Sure, we'd be happy to.
You can definitely talk more about that. Probably needs a research partner. Looking at your panels. But because that needs robustly then collected with a research partner to build that in. But we can, if you're interested, that's cool.
Okay.
Right. What I'd suggest is that we need to move on. We need to let Nye give his talk, but his is fairly short. He's assured me, so we can then hopefully still have time for questions afterwards where we can open it up. So I know you'd like to ask a question. So our final speaker is Nye from University of Bristol. He's essentially going to be talking to us about just transition, in effect, looking at the social science, the social consequences of remaking peatlands through peatscapes. So, Nye, over to you.
just usually your
Marvellous. Thank you so much. Hello, everyone. My name is Naira Maragolo. I'm a postdoc on the Peatscapes project. The project is in form. The PI is Peat Palmer, who's based at the University of Bristol, along with myself. We're looking at 2 sites in the UK. The co-investigator is Peat and Carbon, who's working at the University of Birmingham with the other postdoc, Rosa Ridken. Now, as well as being an ecological challenge, peat restoration is also a potentially contestable social process, which takes different forms across different geographical locations. As the remit of peatland restoration expands, and restoration organisations come into contact with more and more landowners, organisations and local communities, understanding the place-specific social dynamics of peatland restoration becomes ever more important. Peatlands are ecologically diverse, but they're also socially and culturally complex, and as geographers, we're basically looking to understand how this distinctiveness can impact the success and scalability of peatland restoration. So in order to understand these things, we're orienting the project around 2 main questions, which are 1, how do emergent peatland restoration efforts interact with pre-existing knowledges and lived experiences of peatlands? So the relationships between peatland ecologists and other scientists, restoration organisations and local communities are really important. Adopting a geographical perspective, we're interested in exploring how these relationships are shaped by the place-specific social and cultural histories of peatlands in different settings. The goal is to examine how carbon-based restoration imperatives are grappling with different ways of thinking about and living with peatlands in different places. And we'll be drawing on an appreciation of formal knowledge, as well as more emotional connections and embodied ways of relating to the landscape. Secondly, how does knowledge about peatlands circulate, and how is it integrated with new techniques of measuring and restoring peatlands on the ground? So again, from a geographical perspective, we want to look at how the increasingly sophisticated range of scientific approaches to studying peatlands, and especially to measuring the success of peatlands in hydrological, ecological or atmospheric terms, find their ways between different social and cultural contexts, and even get modified as they move from one site to another. That is, we're interested in how different actors draw from and contest scientific arguments, and thereby participate in the production of scientific knowledge. We know a lot more about peatlands now, but there are still a lot of uncertainties about how easy or difficult it might be to generalise knowledge about restoration from one context to another, especially when considering the types of social compromises and trade-offs that will work best in each local context. Speaking of local context, we've got 4 study sites, 2 in the UK and 2 in Estonia. Our British sites are the Great Fen in East Anglia and Honeygard in Somerset Downs. Our Estonian sites are the Lavassaar peatlands, which historically are the most dominant and largest peat mining area in Estonia, which is currently being restored as part of the Horizon 2020 Waterlands project. And the Kolbigiani peatlands, where state-funded restoration projects are existing in tension with forestry and biodiversity values. We hope that the UK sites will be able to provide a wide range of perspective on the restoration work, whilst also remaining reasonably representative of ecological restoration in the UK as a whole. Each of these places is characterised by a distinctive constellation of historical landscape uses and meanings, whether arboreal, archaeological, agricultural or extractivist. And we're interested in how these different socio-cultural atmospheres impact the implementation of peatland restoration as a form of climate change mitigation. The hope is that by understanding these local integrations, we'll be better able to understand the challenges and compromises which might be integral to scaling up peatland restoration. So how are you going to do it? Well, methodologically, we'll be focusing in particular on interviews, participatory photo voice, which I'll explain, and engagement with a range of secondary literatures around peatlands, their histories, and ongoing restoration agendas. The interviews will be split into 2 categories, walking interviews and desk-based interviews. The walking interviews are going to be most appropriate with people involved in the day-to-day work on and around our sites. These will be people like restoration practitioners, volunteers, farmers, and members of the local community. Desk-based interviews interviews, on the other hand, are going to be more appropriate with professionals who, while they might not necessarily be regularly on site, they remain key to their management. People like peatland ecologists, site managers, project funders, and peat extractors. Photo voice is a comparatively new method in the environmental and social sciences. It involves asking participants to take their own photographs of an ongoing environmental process, in our case, peat restoration, as well as to provide a written narrative that explains how these photographs help to reveal the meaning of that process, peat restoration. Photo voice has a number of potential advantages over a straightforward interview. Firstly, it gives agency to our participants to tell their own stories about restoration without implying it was a predetermined or incorrect answer. They also permit a less time-constrained and more open-ended form of expression than simply a verbal answer given in an interview. Finally, this method also helps us to ensure that participants don't feel shut out of the conversation about peat restoration, even if they can't express themselves in a specific language of environmental science. Now, as keen as we are not to shut people out for not being able to use the lexicon of environmental science, we absolutely recognise that as social scientists, we will ourselves need to develop a firm grasp of the scientific processes and practices of measurement which compose peatland science. Geographers like Mark Cooper and George Cusworth have recently called for social science as a whole to pay more attention to the particulars of ecological measurement and analysis. As such, as part of our research, we'll be engaging with the ecological academic literature and project reports, alongside going out into the field to gain hands-on experience with restoration practitioners and ecologists. So far, I've done things like take dipole readings, carbon flux measurements, and recording species, which is a great deal of fun. In terms of our outputs, so this is a 3-year project which began in June of this year, and first going to publish seek to publish 4 peer-reviewed articles in journals on human geography or social science, with each team member leading on one paper. We're also going to put together a series of guidelines for scaling up peatland restoration in a manner that is sensitive to diverse social and cultural contexts. Our project website is currently in development, which will host an online archive of some of our walking interviews, as well as a gallery of photo voice images. Finally, we also hope to host an interdisciplinary symposium at the University of Bristol on peatland restoration as a social and ecological process. Wow, that came in even shorter than I promised. Thank you so much for listening.
That's great. Thanks very much, Nye. And I do love the way when we slide into a different research area, the language and the concepts change. It's a different experience, so thank you. Right, so do we have any specific questions for Nye first, before we throw it open and we'll come back to your question?
Oh, ask about this one.
Yeah.
Can you tell us more about the photo voice and how that works?
Absolutely. So I've read a couple of articles about it. I've never used it before myself. Often it involves giving cameras out to people alongside sort of like sheets, basically, where they record the file name of the photograph, what it's a photograph of in like very narrow terms, and then why they took that photo and why it's relevant to peatland restoration. So in many cases, these will be photos of the site, but not necessarily all the time. These might be things like videos of contractors entering a site through a village, or and so that'll be useful, and it will also be useful potentially for qualifying some of the conversations that we have in an interview, because it might provide like a useful foil to talk about people's photographs during an interview, as well as just standing up to an answer.
Any other particular questions? Yes?
You said about the 4 sites that obviously they picked those for a reason. Could you go into a bit more detail about how those sites were specifically picked?
Absolutely. So they provide a really wide range of former uses and sort of cultural heritages. There's a lot of crossover between them, of course. You know, a lot of places were used for peat extraction and subsequently for agriculture. On the Somerset levels, you've got a really very strong archaeological background. The East Anglian Fens are a classic, in fact, the archetypal British example, perhaps, of sort of long-term peatland drainage for conversion to agriculture. The Lavasar peatlands are a massive site of peat extraction and mining, where I think either nearby or on the actual whole complex, peat extraction is still taking place. And the Colbiani peatlands provide really, basically an interesting site for thinking about the relationship between peatland restoration and woodland, which is an interesting sort of potential tension for us to explore.
So on the site, so you've got these sites. What are the boundaries? Where do you draw the boundary around the site? Because do you speak to the neighbours? Do you speak to the people that are looking at that and thinking that's like, you know, these people are, you know, I know the two sites in the UK, they're going to maybe adopt to as well as quite down the restoration road. You know, I also know some of the other communities in those areas of Newlands. You're going to speak to all of those people?
Yes.
So the site is a kind of focal point.
Yeah, the site's certainly a focal point. It's not the limit of our interest. Definitely sort of like the towns and communities, community groups, local to the sites will absolutely, yeah, be.
Can I ask a related question? How are you identifying who to speak to?
Yeah, great question. Basically it's, first of all, by working through people in restoration organisations, the BCMWT and the SWT, who've been fabulous, but then also, trying to, so firstly, sending emails, just sending a lot of emails to particularly concerned local businesses and organisations, but yeah, also getting on the ground and being in these communities is just going to be really cool, and has been really useful so far. So yeah, just being around and setting up a lot of communiques and getting some responses.
That's always the challenge. Any more? No? In which case, thank you very much, Nye. I'm going to throw the floor open. We have 10 minutes to explore any other thoughts, questions that have arisen in your minds while we've been going through this. I know you have a question.
So I just wondered, do you have a methodology even for buried peat? You know, so some of the sites we just haven't been to them, like some of the fens or something. You know, we're still at the beginning of that. But we kind of know what we're doing because it's probably similar to the uplands. And I'm just wondering with the buried peat, where do we start? Have we even started to think about where we start?
We started to. The problem with buried peat is buried. And we don't really know very well where all the peat is on the surface. So knowing where it's buried is quite challenging. So the conversation we had at a visit a couple of weeks, there's also, around here, there's all sorts of problems with buried peat. You know, there's different layers of peat formation and marine sediments and that kind of stuff. But there's also the stuff that's happened through management. So there's these things called peat holes, which one of the farmers that we work quite closely with is very keen to tell people about. And this is people who've dug a hole through the peat, moved the peat to the side, dug a load of clay out, chucked the clay on top to increase the fertility of the land, and filled it back in so the peat you live in dirt profile. And so what you've got is large areas of this sort of egg shape, undulating thing, and people can deprecate on that, and there's two ways to look at that. You can think, oh no, there's all peat there and that's a risk, or you can think, well actually the peat layer is sort of deeper than we thought, because it's not just. So we've looked at, there's a chap retired who's been pushing this very peat thing for quite a long time, Steve Warman. He's a geologist, so he comes at it from that sort of perspective. In terms of what it's doing and how active it is, that's a good question. But to measure it, you need to know where it is, and that kind of means digging a hole or having some fancy radar thing. So it's quite challenging.
Yeah, in fact, I was talking to Chris Miller, who's running the Natural England Peat Survey, and he was saying that identifying areas with only about 18 centimetres, 20 centimetres of peat, then a relatively thin clay layer, then 3 metres of peat below. So of course, once the 20 centimetres is gone and the plough is going into that clay layer, it's going to expose those 3 metres of peat. So yeah, it's an interesting challenge. Yeah, very good question. Any more thoughts, questions, comments from anyone? Yeah, Chris.
About the methane, about the presentation, was talking about taking off, the top layer of soil that's got a lot of nutrients in it. If you inverted it, so you dug out a square, turn it upside down, put it upside down, so the nutrients are buried, what do you think, is that methane, is there still going to get methane coming out?
I think I'll offer that.
Depends what's going on in that profile and what's going on in the peat. So if you've got those shunt species that are rooted down there and can move the gases up and down, then maybe it's, that could happen. And then if the rest of the bit above it is oxic, then you get methanotropy on the bubbles up. So there's, it sounds like an interesting experiment.
Yeah, we could actually try that on the Lancashire. Some areas. We're calling it bog squashing.
Squashing. Yes. But of course, if the surface there is rich in roots or labile material, and you turn it upside down and you put it into the water table, so it's then waterlogged, then that will tend to produce methane. Right. So as Ross said, it kind of depends exactly what you're dealing with, what's going on. It's a good issue, good question. Any more? Oh, Ross has a question just before Ross.
Trees on peat, really?
Trees on peat?
Yeah, so they're doing the forest development. This just, to me, I know some people who attend this just seems, how do you baseline this? How are you thinking you're going to do this? The only way you can think you can do it is some sort of price sequence. If you're going to know the answer to that question, you are talking towers and forests and
Yep. So what we're talking about is plantation at the moment the thinking is for plantation that's coming to the end of the rotation, so the trees have been taken off anyway, because it's deep peats, they are unlikely to be replanted and they want to restore. So the baseline then is this felled site that then needs money for restoration. But that's a political issue of can we agree that is, and then the other issue is within the carbon project, can we say that that's your baseline because we've taken trees off, what's happening to that? But those trees are going off anyway because it's the end of the rotation. So that would happen regardless of your carbon project. So yeah, but that's what we want to check. So we want to check what is actually, you don't have those sites that have felt and then left them. So we have got FLS and RTB on board to get us to do some measurements on some of the sites. And we also discussed government for funding for that. So hopefully we can get that, at least checking that we can start that now.
But that's the starting point, is clear fell, you're off.
Yeah. Forest research are not doing something like research, okay, I thought we were.
Maybe it's very little, but I don't think there's very little research being done on sites that are left. Cotton left.
Anyone I've ever seen too?
Yeah, they're not left anymore.
Well, that's good.
And certainly we get the data on restored stuff, but not obvious.
Okay, if there's no further questions, we are 4 minutes within our time scale. So well done everybody. And it does mean that you are 4 minutes early for lunch.